Hi, my name is Shema, and this is my CubeSat Telemetry Dashboard Simulator project. A CubeSat is a class of nanosatellites with a standard size that are cheaper and faster to build than traditional satellites, and they're often used by university students as hands-on educational tools to allow them to gain real engineering experience. This project is an automated satellite health monitoring dashboard that simulates real-time telemetry for CubeSat in low Earth orbit, and it automatically watches that data for problems without having someone manually check it. This project is built for university CubeSat teams who need a free and accessible way to monitor satellite health without using expensive commercial software. Here's the main screen, and there's a Start Mission button which will lead you to the dashboard. Under it is just a few brief instructions on how to run the simulation, but that will also be shown again in the dashboard. Now let's press this button. Now here's the dashboard. On the top, this is just all the metrics that this simulator focuses on regarding the CubeSat. So this will include CubeSat battery percentage, the environmental temperature, signal strength, solar winds, debris distance, and radiation levels. The cycle here, it just means check-ins, like how many times that this CubeSat is checked in on. Under this table is a health score. That's just going to take all the numbers in this table here and calculate the overall functionality of the CubeSat during the entire course of the mission. And under it is just a list of the safe ranges for each of these metrics. You can also affect some of these numbers yourself by triggering anomalies, which are these buttons here. For example, if I wanted to cause the battery to drop, I can press the battery drop button. When I unpause the simulation, you'll see that the battery went from 97 to 62. Additionally, I can also set my own custom values. For example, if I wanted to set the solar wind to exactly 800, I can do that. Currently it's at 409, so now I'm going to press 800. And also there's a drop-down menu if you want to choose other variables. Press the set value. Now I unpause the simulation, and you'll see that it went to exactly 800.0. Once I'm finished with the simulation, I'll press the Stop Mission button, and it will generate a mission summary report for me. It will give me my final health score of the mission, the total anomalies it logged, and how many of them were labeled as critical and warning. It will also tell me the first anomaly it found and also the most recent one. It will also generate an event log below, which will just tell you when all the anomalies were found. Additionally, you can press this to see the score reference. It will just tell you which health score ranges are associated with which label. Additionally, if your mission has no anomalies whatsoever, this was what the mission report would look like. There would be no event log because there were no anomalies found. Then when you press close, it returns you back to the home screen because the mission has concluded. And if you were to press Start Mission again, it would reset everything for you. Here's a rundown of my code. Here are the initial values for each of the metrics. This function here is what allows you to trigger anomalies. Here's what is used to detect anomalies. And this is what's used to calculate the health score and to label it as well. And this is used to generate the event log. Here are some of my visuals for the main window, and the background, and the start screen as well, and the text I included. These are the visuals for the dashboard screen and the GIF that I put on the right side of the dashboard. This is also some of the text I included. This is for the pause and stop button. Here are some of the command buttons. This will show the report window, where the mission summary is. The core pieces of this project is the automated detection, scoring, logging, and reporting of data. In the real world, small satellite teams often rely on manually checking dashboards to catch problems with their CubeSats. But this system is designed to help with that by replacing the slow and error-prone manual process of checking the data. In the future, I can see the same automated monitoring approach being used for other applications beyond just CubeSats. I believe that it could be used for any sensor-based system where catching a problem early truly matters. That concludes my CubeSat telemetry dashboard project. Thank you for listening.